Welcome back to Mr. Powers. I'm Mr. Powers. We're teaching algebra. We're talking about functions. And my last video, we went over this working definition that I stole from Paul's math notes. You can find those easily online. And pretty much is saying for every element our function is defined for, every x value, there is one y value that is assigned to it, or it gets matched to one y value, right? There's one y value that makes the equation true, not two. And so we did a couple equations. We tried y equals 5x plus 1, and we found we were pretty convinced. Test a couple x values. We only get one y value. We know we're just multiplying our x and then adding to it. And there's only one answer you get when you multiply or when you add. We know that. We've been multiplying and adding for a long time, so we could tell that's a function. And then we had this weird guy, y squared equals x plus 1. And we could easily see we only test one value because when x is 0, we got two solutions for y. So like right away, we don't need to test anymore. We know it's not a function for sure. And so we don't even have to think about it. But our problem was when you're going to solve for y given an x, we're taking a square root. And that leads to possibly two solutions. When you take a square root, you get a plus or minus. So we're like, okay, so we're going to have two y's for every x, or almost every x, unless we get a 0 over here. So when x is negative 1, I think we get one y. But otherwise, we're getting 2. Okay, so what about visually, right? What about visually? We're going with this definition here. How does that translate visually, graphically? Okay, so we got this graph up here. And I got a couple. You can see over here right now what it's showing. All I did was I typed in geogebra.org/calculator. You can see it up there. It says graphing. I'm in the graphing mode. Okay, it does all sorts of fun stuff. I use the probability a lot. I use CAS sometimes, really powerful. 3D calculator I haven't messed with. Well, I mess with other things people made with it. But anyway, okay, going on. So we got this equation. I typed in y equals 5x plus 1. I get the graph. And then I went ahead and I got x equals 0 in here. X equals 0. And you'll notice what happens when I type in x equals 0, it's going to cross our graph, y equals 5x plus 1. And if you remember, too, I'm put a point up here. Oops. Okay, there we go. I got, there we go. I got a point, and I can drag this point around. And remember, each of these points is a solution to that equation. Sorry, y equals 5x plus 1. 5 times 1.005 plus 1 is 6.025. And so on, of course. Nice numbers here, nice number there. There's a nice number right here. We get negative 1, comma negative 4. All these are solutions to this equation, right? And we can easily see dragging this around like, yeah, every x is only going to have one y. But why is that? Well, if you take a look at this vertical line, there we go. We take a look at this vertical line here. It crosses at one point on here. Right now, this is x equals 0. And you can see the value for the point where they intersect, x is 0. That makes sense because every point on this line is, I'm probably being a little bit more thorough than I need to, but every point on y equals 0, or x equals 0, sorry, is that x is always 0, no matter what. X is 0. That's why it's a vertical line, right? So all you got to do, if we're looking at a graph, is imagine a vertical line sweeping across our function. As long as the vertical line will only intersect with our graph in one point, well, then we know there's one y for every x. If, however, it crosses at 2 points, then we know it's not true. And so here, I'll illustrate that. So I'm going to go ahead and I'm going to hide this here. We don't need to see that right now. We don't need to see that anymore. And just to remind you, 0, 1, that is what we got. I plugged in 0, we got 1. We plugged in 1, we got 6. So if we swipe our x equals over a little bit, if I can get to 1, if my mouse was better, I could do it. Or I just type in 1. There we go. We got 1 comma 6. All right, so let's look at that other graph that we had. So I'll take this one away, and I'll put in the other graph, which was y squared equals x plus 1. I got that right here. Turn that on, and you can see right away there's 2 places it's intersecting for x equals 1. And I can slide it around. It intersects in 2 places a lot. That means it's not a function. That means for those x values, there's more than one y. And we can see exactly what those are. Again, if I want to mess with this, I can click there. I can click here. I'm going to say, show me. Let's see that. What do we get? All right. X is 2.8. One of them, the y is 1.95. The other is negative 1.95. I get 2 different y's for the same x. Not okay. So we can see graphically, this is just a long-winded explanation of what's called the vertical line test. And so you can see it's super easy that we can see that there's tons of places where we got the same x but 2 different y values. X is 3, y could be negative 2 or 2. Not okay, not a function. And of course we tried 0, 0, negative 1, 0, 1. That's what we got when we did it by hand. 0, 1, and 0, negative 1 points on the line. All right, I think that's enough. So the deal is, what's the vertical line test? If you imagine a vertical line going through the graph, if it can only cross our graph in one place, it's going to be a function. If it can cross in more than one, a vertical line, it's not a function. That's our vertical line test. And there you go. It's as easy as that. So thanks for putting up with this video. Till next time, enjoy doing math.